Dear students, welcome to Nivi's Patashala. In this video, we will be studying about deterministic finite automata. Let us construct a DFA to accept strings of zeros and ones ending with 0, 1 or 1, 0, which means my DFA should accept n length of string which ends with 0, 1 or the string is ending with 1, 0. So the minimum string is 0, 1 or 1, 0. The input symbols, that is the alphabets, are 1 and 0. Let us construct the skeleton DFA for 0, 1 and 1, 0. So for 0, 1, the length of the string is 2, that is 0 and 1. So the minimum states I will require is 2 plus 1. So I have 3 states, Q0, Q1 and Q2, where Q2 is the final state which is accepting 0 and 1. Now let us give the skeleton for 1, 0. So again the length of the string is 2. So the minimum states I will need is 2 plus 1. So I have Q0, Q1 and Q2, 3 states where Q2 is the final state which is accepting 1, 0. Now in DFA I can never have two start states. I can always have only one start state, but I can have n number of final states. So when I club these two skeleton diagrams together, I am having one start state where I have 0, 1 also accepted here in Q2 and I have 1, 0 also accepted here in Q4. So totally I have 5 states, Q0, Q1, Q2, Q3 and Q4, where Q0 is the start state and 0, 1 is accepted by Q2, which is a final state, and 1, 0 is accepted by Q4, which is also a final state. So I have one start state and I have two final states. Let us give the transition for this. So Q0 on input 0 going to Q1, Q0 on input 0 going to Q1, Q1 on input 1 going to Q2, Q0 on input 1 going to Q3 and Q3 on input 0 is going to Q4. This is the transition table. We have filled the cells for which we have the transitions. Now let us analyze the problem by seeing few accepting strings and rejecting strings. Now if my string is ending with 0, 1, all those strings are supposed to be accepted. So 0, 1 is accepted. N number of ones ending with 0, 1 is accepted. N number of zeros ending with 0, 1 is accepted. Or n number of combinations of zeros and ones which is ending with 0, 1 is accepted by the DFA. Now if the string is ending with 1, 0, this also has to be accepted by the DFA. So the minimum string is 1, 0 which has been accepted. N number of zeros ending with 1, 0 should be accepted. N number of ones ending with 1, 0 should be accepted, or combination of zeros and ones which are ending with 1, 0 has to be accepted. So the overall accepting strings can be, if I have 1, 0, 1, this is ending with 0, 1, so this is accepted. If I have 0, 1, 0, this is ending with 1, 0, so this also has to be accepted. So n number of combinations of zeros and ones which are ending with 1, 0 or ending with 0, 1 has to be accepted. What are the rejecting strings? If my string is only 1, it has to be rejected. If my string is only 0, it has to be rejected. If my string is 1, 1, it has to be rejected. Or if my string is 0, 0, this is also rejected. Or n number of combinations of ones and zeros ending with 1, 1, or if it is ending with 0, 0, it has to be rejected. If it is ending with 0, 1, or if it is ending with 1, 0, it has to be accepted. So here we have few accepting strings. Let us complete constructing the DFA. If I have n number of ones ending with 1, 0. So ending with 1, 0, we know the transition is happening from Q0 to Q3 and from Q3 to Q4, because here 1, 0 is being accepted here in the final state. Now if I have n number of ones, I will loop them in Q3. So the first one moves from Q0 to Q3 and the remaining ones get looped in Q3 ending with 0 reaches Q4, which is the final state. The same way, if I have n number of zeros ending with 0, 1. We know that for 0, 1 the transitions move from Q0 to Q1 and from Q1 to Q2, where Q2 is the final state which is accepting 0, 1. So I will loop the first 0 moving from Q0 to Q1 and the rest of the zeros to be looped in Q1 ending with 1, that is ending with 0, 1 is being accepted in the final state. Next I have 0, 0, 1, 1, 0. So now first 0 moves from Q0 to Q1. The second 0 gets looped in Q1 and 1 moves to Q2. Now again my string is ending with 1, 0, which is supposed to be in a final state, which is supposed to be accepted. So therefore I am giving that 1 from Q2 to Q3 and ending with 0, that is Q4. Now if I have 1, 1, 0, 0, 1. So the first one moves from Q0 to Q3 and the second one gets looped in Q3 and 0 moves to Q4. It is ending with 0, 1. So now I have to give that 0 to Q1. So that 0 is moving from Q4 to Q1 and it is going to Q2, that is ending with 0, 1. I cannot loop 1 here or I cannot loop 0 here. If I loop 1 here, what happens? A string that is 0, 1, 1 has to be rejected, but if I loop 1 here, it gets accepted. If I loop 0 here, a string that is 1, 0, 0 has to be rejected, but it will get accepted if I loop 0 here. Therefore, I cannot loop. I am giving 1 from Q2 to Q3 and I am giving 0 from Q4 to Q1. Now if my string is 0, 1, 1, it is supposed to be rejected. So from Q0, 0 goes to Q1 and from Q1, 1 is going to Q2. If I have 1 again, the string has to be rejected. So 1 is coming here to Q3, which is a non-final state, which means 0, 1, 1 is rejected. The same way if I have 1, 0, 0, it has to be rejected. So from Q0 I have 1 going to Q3, 0 goes to Q4 and again 0 comes to Q1. So 1, 0, 0 is in a non-final state, therefore the string is said to be rejected. Now if I have a string starting with 0 and n number of ones, it has to be rejected. So 0, 1 is accepted. After that if I have n number of ones, that comes to Q3 and gets looped and stays here until and unless it ends with a 0, which is having ending with 1, 0. So the same way if I have a string starting with 1 and ending with n number of zeros, all those zeros are getting looped in Q1. Now if I have 1, 0, 1. So I have 1 coming from Q0 to Q3 and 0 going from Q3 to Q4 and again I have 1 which is supposed to be accepted. So I cannot loop 1 here because 1, 1 also might get accepted. So instead I will give that 1 to Q2. So 1, 0, 1. Now Q2 is also a final state. So therefore if my string is only 1, 0, that is also accepted. If my string is 1, 0, 1, that is also accepted because it is in the final state. Now if I have 0, 1, 0, so then I am going from Q0 to Q1, 0, from Q1 to Q2, 1, another 0 I am giving to Q4, which is also a final state. Therefore 0, 1, 0 is also being accepted. Now if I have 0, 1, 0, 0, 0, it has to be rejected. So what happens? 0, 1, 0 is in the final state. Now if I have n number of zeros, it should get rejected. So the next 0 is going to Q1 and n number of zeros will remain in Q1 itself. The same way, if I have 1, 0, 1 and n number of ones ending with 1, 1 should be rejected. So those n number of ones will come to Q3 and they will remain in Q3 itself until and unless they end with 0, which will reach the final state. So now we have the transition table for the DFA. So we have the completed DFA. The mathematical representation is Q for all the states. I have Q0, Q1, Q2, Q3 and Q4. These are all my states. The input alphabets is 0 and 1. The start state is Q0 and the final state is Q2 and Q4. And the transitions, we have the transition here. That is Q0 on input 0 going to Q1, Q0 on input 1 going to Q3. So we have all the transitions here with respect to the completed DFA. Let us see what is a trap state and a dead state. So first let us see a trap state, a state for which there exists transitions to itself for all the input symbols in the final state, which means, see here I have a diagram where I need at least one B to reach the final state. If I have n number of A's, I am still in Q0, which is a non-final state. I need at least one B, minimum of one B to reach the final state. After reaching the final state, n number of A's and B's are in Q1 itself, are in final state itself. So my string needs at least one B to reach the final state. So here A and B both are getting looped in Q1 itself, for which there are no other transitions happening to any other state. So if this kind of an action happens in a final state, we call this to be the trap state. That is, A's and B's are being accepted by Q1 itself. There are no transition happening to any other state. Now what is a dead state? If this kind of a situation happens to a non-final state, then we call it to be a dead state. See, in this diagram here, we need at least one B to reach Q1, which means the string, if it is having n number of A's, it is in Q0 itself. It needs at least one B to reach Q1, but if it has another B, then it is going into a dead state. So which means the entire DFA accepts only strings that are having only one B in it. So if I have another B, then it is going into a dead state where all the transitions again are happening in Q2 itself. So n number of A's will be in Q0 itself. If I have one B, n number of A's, and then if I have one B, then it is going into a final state. After having a B, if I have n number of A's, it is staying in the final state itself. But if I encounter another B, that is a second B, then it is going into a dead state, where after that n number of A's and B's are remaining in that state itself. So from Q2, I am not having any transitions to any other state. So therefore Q2 is called the dead state because it is not a final state. If this kind of situation happens to a final state, we call it a trap state. If it happens to a non-final state, we call it to be a dead state. Let us look at this example. Construct a DFA to accept strings of zeros and ones ending with 1, 0, 0. This example can also be used as a reference for strings of A's and B's ending with ABB, or strings of A's and B's ending with BAA. This example is a reference for all those kinds of problems. So the accepting strings are any string that is ending with 1, 0, 0. So if I have n number of zeros ending with 100, it has to be accepted. If I have n number of ones ending with 100, it has to be accepted. Or combinations of ones and zeros that are ending with 100 has to be accepted. So what are the rejecting strings? If I have only 10, or if I have 00, or if I have 1, or if I have 111, or if I have 01 or 10, or any strings that are not ending with 100. Here the strings are ending with 011, this has to be rejected. Ending with 010 has to be rejected. 010 rejected. 001 rejected. It should be accepted only if it is ending with 100. So my minimum string is 100. So the length of the string is 3. I will be requiring 3 plus 1 states, that is 4 states. So my input alphabet is 0 and 1, and the skeleton DFA I have 4 states, Q0, Q1, Q2 and Q3, where Q3 is the final state which is accepting the input string 100. So let us write the transition. Q0 on input 1 is going to Q1, Q1 on input 0 is going to Q2, Q2 on input 0 is going to Q3. Let us give the transition table. Always don't forget to mark the start state and the final state. So we have the Q0 on input 1 going to Q1, Q1 on 0 goes to Q2, Q2 on 0 goes to Q3. Now let us complete constructing the DFA. Now if my string is 100, it is accepted, that is 100 is reaching the final state, that is Q3, it is accepted. If I have n number of zeros ending with 100, I am looping n number of zeros in Q0 ending with 100. So Q0 on zeros is being looped in Q0 itself. Now if I have n number of ones ending with 100, the first one moves from Q0 to Q1, and then n number of ones get looped in Q1 ending with 100. Next I have 101 ending with 100, which has to be accepted. Now if I loop 10, if I loop 1 here, what will happen if my string is 1010? It has to be rejected. 1010 has to be rejected. So if I loop 1 in Q2, what happens? 1 0 and 1 0 is getting accepted. Therefore, I cannot loop 1 in Q2. Instead, I will send back that 1 to Q1. So if I have 1 0 1 and n number of ones will get looped in Q1 ending with 0 0. Now we have 1 0 0 1 0 0. So I have 1 0 0. I have reached the final state. Again I have 1 0 0. So if I loop 1 here in Q3, then n number of ones will reach the final state. Therefore I cannot loop 1 in Q3. Instead I will give that 1 again to Q1. So 1 0 0, again 1 0 0. If I have n number of ones in between, it will be in Q1 itself until and unless it ends with 0 0. So 1 0 0 will reach the final state. Now I have 1 0 0 and then n number of zeros again ending with 1 0 0. So I have come to the final state with 1 0 0. Now Q3 is encountering n number of zeros. So I am giving that n number of zeros to Q0. I cannot loop n number of zeros in Q3 because then 1 0 0 0 0 also will be in final state where the DFA is not correct. So I am giving those zeros back to Q0. So n number of zeros also will get looped in Q0 and 1 0 0 is being accepted by the DFA. So now we have our transition table to be completed. These are the transitions and representing in the mathematical format where Q is all the states, that is Q0, Q1, Q2, Q3, and the alphabets are 0 and 1. The input symbols are 0 and 1, where Q0 is the start state and Q3 is the final state. And the transitions are here. We can write down the transition with reference to the diagram or with reference to the table. So Q0 on input 1 goes to Q1, Q2 on input 0 goes to Q3. The same way the transitions for all the states with input 0 and input 1 has to be written. That is Q0 on 0, Q0 on 1, Q1 on 0, Q1 on 1, Q2 on 0, Q2 on 1, and Q3 on 0 and Q3 on 1. The transitions are given here. So now look at this example. We just finished constructing a DFA to accept strings of zeros and ones ending with 100. Now here I have which do not end with 100, which means the strings that do not end with 100 are supposed to be accepted by the DFA. So let us see the analysis. So the accepting strings are 0, only 00 or n number of zeros, or ones, 2 ones or 3 ones or n number of ones, or 10 or 01 or 101. All these are the accepting strings. So what are the rejecting strings? Any string that ends with 100 has to be rejected. In the previous problem we saw that any string that is ending with 100 has to be accepted. Here any string ending with 100 has to be rejected. The rest of the strings are supposed to be accepted. Any string that does not end with 100 has to be accepted. So here again the minimum string is 100, which ends, that is it is in a non-final state. So the minimum string which do not end with 100. So the minimum string is 100, which has to be in a non-final state, which means this minimum string has to be rejected. All these while we constructed the minimum string that has to be accepted. Here this is the minimum string that has to be rejected. So the input alphabets are 0 and 1. Now here we have the skeleton diagram, where it means 100 should be in a non-final state. So here I have 1, 0, 0, which is in a non-final state, which means only 1 is being accepted, 0 is being accepted, 10 is being accepted. All these are in final states. If I get 100, it has to be rejected, which is in a non-final state. So these are the transitions. Q0 on 1 goes to Q1, Q1 on 0 goes to Q2, Q2 on 0 goes to Q3. So in this transition table we have Q0, which is a start state and also a final state. Q1 is a final state, Q2 is the final state, where Q3 is just a normal state. And the input alphabets are 0, 1, and we have written the transitions. Q0 on 1 goes to Q1, Q1 on 0 goes to Q2, and Q2 on 0 goes to Q3. So now let us complete the construction of the DFA and give its mathematical format. We know that this is the skeleton diagram where 100 is being rejected. So if I have the string to be 0 or n number of zeros, the DFA has to accept it. So I am looping zeros in Q0. 0 is accepted, 0, 0 is accepted, n number of zeros are also accepted because Q0 is a final state. Let us fill the transition table. Now if I have n number of ones, 1 and n number of ones, this also has to be accepted. So Q0 on 1 is going to Q1 and n number of ones I am looping in Q1, which is also accepted. Now if I have 101 or 10111, if I loop that 1 in Q2, if I loop 10111 in Q2, what happens? 1, 0, 1, 1, 1 is in final state. So yes, the DFA is accepting 10111. Now if my string is 1010, this is also an accepting string, isn't it? Because it is not ending with 100. So if I have 1010, this should also be accepted. What happens? 1, 0, 1, 0 is being rejected because it is going to a non-final state, which means the DFA is rejecting the string. So if I have 1, 0, n number of ones, 0, this should also be accepted where the DFA is actually rejecting it. So therefore, I cannot loop 1 in Q2 because the DFA is rejecting the accepting strings. So instead, what I can do is from Q2, I will give 1 to Q1. So if I have 1, 0, 1, it is in a final state. If I have 1, 0, n number of ones ending with 0, it is in Q2, which is also a final state. If I have 1, 0, 1 ending with 0, 0, that is 1, 0, 0, 1, 0, 0 reaches Q3, which is a non-final state. Now if I have 1, 0, 0, 1, this also has to be accepted. So I cannot loop 1 here because it will reject the accepting strings. So instead, if I have 1, 0, 0, 1, I am giving back that 1 to Q1. If I have 1, 0, 0, 0, which is a accepting string, I am giving that 0 to Q0. So 1, 0, 0 will get rejected. If I have another 0, it goes to Q0, which is a final state where the string is being accepted. So let us complete the transition table and write the mathematical representation. Q is all the states, that is Q0, Q1, Q2 and Q3. The input symbols are 0, 1. The start state is Q0 and the final state is Q0, Q1 and Q2. Here we have written the transitions with respect to the diagram or the transition table. We can see that in the string ending with 100 has to be accepted. Q3 was the final state. In the string ending with 100 has to be rejected. We have Q0, Q1 and Q2 to be the final state. Apart from that, the transitions are all similar to the DFA which we constructed for strings ending with 100 which are being accepted. Thank you for watching and don't forget to like, share and subscribe.